This differential equation operator notation is going to allow us to do kind of complicated, it's going to allow us to do pretty complicated differential equations. So for example, we could look at d minus 1 cubed times d squared plus 6d plus 10 times d squared minus 25 y equals 0. And so this would be a 7th degree differential equation, homogeneous, linear, constant coefficients. But we've already done all the, the algebra is there already. So we really just have to solve the 7th degree equation, r minus 1 cubed times r squared plus 6r plus 10 times the quantity r squared minus 25 equals 0. And the first and middle terms are straightforward enough. You have r equals 1, which is going to be a solution of multiplicity 3. R squared minus 25 tells you that you have r equals 5 and r equals negative 5, each of multiplicity 1, because you can factor them as r minus 5 times r plus 5, both to the first. And then, so multiplicity 1. And then the middle term, we need to think about what's going to happen there. So r squared plus 6r plus 10 is going to be equal to r squared plus 6r plus 9 equals negative 1. So I'm completing the square. And that means that r plus 3 squared is going to be negative 1. And therefore, r plus 3 is going to be equal to plus or minus the square root of negative 1. So r is going to be negative 3 plus or minus I. Turns out that those are the solutions there. Those come in pairs. We have two complex numbers, each of multiplicity 1, but they come in pairs. So I'm going to write them together. And therefore, our solution that we're going to have, our general solution is we're going to have c1 e to the 1x plus c2 x e to the 1x plus c3 x squared e to the 1x. And we have multiplicity 3 for the solution. So that means that we're going to have 3 e to the x terms. So we'll have a constant times x, and a constant times x squared in front there. And I'm going to need a little bit more room. So let's squeeze this in here. So we'll just move these terms over just a little bit. All right. The r equals 5 and r equals negative 5. Not much to really talk about there. You got c4 e to the 5x plus c5 e to the negative 5x. And then finally, the negative 3 plus or minus I, we know what that looks like as well. That's going to be e to the negative 3x times the quantity cosine of x. And as much as I tried, I need to go into a new line. So plus e to the negative 3x times c1 cosine of 1x plus c2 sine of 1x. Because this is negative 3 plus or minus 1i. So that's why you had a 1i here and therefore a 1x there. Okay, but that's what the general solution is going to look like.